this EV State Working Group meeting. This one we're hosting instead of the last Tuesday in September. We've pushed this one to October because of the fantastic conferences that we had last week in Detroit, in my hometown. So it was wonderful seeing so many of you there last week. There were, I think, 3 overlapping conferences, or at least coordinating conferences. The first being the NASIO AASHTO conference that I saw many of our EV State Working Group members at. And we had some really fantastic discussions getting into how states are supporting the EV transition and planning for the future of electric vehicles. Then there was the National EV Charging Initiative that I saw many of you at as well. And then finally the 4th Mobility Conference, which ended up having a really great turnout. So it was really, really great to see the city of Detroit, the original home to automobiles and auto manufacturing, be at the center of the EV discussion. So thanks to many of you for joining and participating in that. Today, you can see our agenda on your screen there. We've got a fantastic conversation. Today, we're talking about the energizing chargers faster. So how are we actually bringing these large powered, high power and electric vehicle charging systems online faster? And we've got 3 fantastic speakers to go through this with us today. DJ Anand from the Joint Office, Britta from EPRI. You've probably heard her speak primarily about the EVs to Scale 2030 initiative that she is leading up. But today she's actually going to be talking about a different initiative, also EV related, that she's also leading. So this might be the first time hearing about this one for some of you. And then also Paul Martini from Newport Consulting. Just like we do every month, we'll hold our speaker Q&A until all 3 speakers have presented. So, and then we'll bring all 3 speakers back on video and be able to ask all of the questions simultaneously. And then after that speaker Q&A, we'll go to our closed peer sharing discussion where it's only the commissioners and commission staff who are participating in that to allow for some more open dialogue. We stop recording at that point and keep that as a closed session. All right, with that, we can head to the next slide. Oh, yes. So the EV case study catalog is a really fantastic list of resources that Robert and Danielle and their team has put together at CPI. It's a catalog to connect commissioners and staff to existing reports on emerging utility regulatory approaches to EV related questions. And they've started putting together this great and very easy to use catalog that features lots of resources. They've got over 25 in there right now, including a lot of different reports, references to commission decisions, utility programs, pilots, and more from a host of different states, many of your states who are on this call today. Some of the resources in the catalog cover several regulatory issues and topics, such as how to prepare the grid for medium and heavy duty charging, among many, many other things. And I see that we've got the link to that in the chat. Definitely encourage you to check that out and scroll through, just so you can, it's really useful to have, feel like we hear about a new study on electric vehicles and their associated charging every week, it seems like. And this is a really good comprehensive place where you can go and see them all listed there together. There are resources from groups like the Alliance for Auto Innovators, from the DOE, from Lawrence Berkeley National Lab, from AEU, from the Joint Office, from NARUC, from SEPA. There's just a large host of resources that are available to you and your staff. So thanks to the CPI team for putting that together. All right, Robert, you can move on to the next slide. Okay, fantastic. All right, so we'll get into our 3 presentations from our guest speakers. Our first guest speaker is from the Joint Office, DJ Anand. DJ works in the Standards, Reliability, and Cybersecurity Program at the Joint Office of Energy and Transportation and is presenting on behalf of the Utility Program's principal, Sejal Shah. Prior to the Joint Office, DJ was the lead scientist for the Smart Grid program at NIST and has worked in various capacities supporting research and standards developments for critical infrastructure. So with that, DJ, I'll hand it off to you for your presentation.
Hello, good afternoon. So yeah, my name is DJ Anand, and as was mentioned, I'm covering for Sejal Shah, who is your sort of primary contact for utility programs. She's the Joint Office's senior advisor in that field. Go to the next slide. So yeah, I'll give you a quick update on NEVI. So most of you are probably extremely familiar with the electric vehicle infrastructure program. And the sort of highlight of today is the new program that is getting started in coordination with OEE and CETO and VETO and some other offices, which is IQMS, the Innovative Queue Management Solutions funding opportunity. So go to the next slide. All right, for those of you that don't know what the Joint Office is, go to the next slide. We are sort of a special purpose organization that transcends the boundaries between DOE and DOT, and with the sole objective of accelerating the pace at which we develop the electric infrastructure needed to support electric mobility, and then achieving some sort of broad spectrum goals that the government has in making this infrastructure affordable, convenient, equitable, reliable, and safe. And on the reliable and safe front is where I primarily work. I work on the standards and reliability side of things. So the engineering of this infrastructure is particularly what I work on. So go to the next slide. Just to sort of like level set expectations, we are still seeing some pretty positive numbers in EV adoption. Right now, I think we're about 1 in every 10 new vehicles sold is an electric vehicle. And despite some press that might be a little bit pessimistic sometimes, we are still seeing positive growth rate in EVs. And to give you sort of a sense, in the projections for EV adoption, the current growth rate still fits well within the margins that were assumed between the low and mid scenario. So we still expect that there will be about 10 times as many EVs as today by 2030. And to support that, the goal that we have been set is to build a network of 500,000 public chargers by that time. So you can go next slide. There's a whole bunch of programs that we're working on at the same time in parallel, ranging from small electric vehicles all the way to medium and heavy duty vehicles and transit buses. I won't go into these in detail. This I think has been covered before from what I hear. Let's go to the next slide. To give you an update, all the states have submitted plans. They're all getting money from the federal government at the moment. And if you go to the next slide, to give you a quick snapshot of where things are right now, about 40 states have released solicitations for infrastructure construction. And then there are about 800 locations. That's 3,200 fast charging ports that have been awarded. 9 states have NEVI stations already open. Things are going pretty well, is basically the takeaway. Some headlines for you, and they're all over the country. In Kentucky recently opened one. Governor Beshear cut the ribbon. So yeah, so things are going pretty well on the NEVI front. So go to the next slide. But the topic that we're covering today is there's still a pretty significant issue with speeding up the pace at which we can get these chargers in the ground and turned on. And that's where we're trying to work on several different things sort of proactively. Just as an aside on the general charging infrastructure and improving the experience of charging, we've been working there for a fair length of time, more than a year, in simplifying the ecosystem and improving the reliability. I know for all of you here, reliability is a top concern. You are responsible for perhaps one of the most reliable pieces of infrastructure we have in the country. And EV charging has a lot to learn from the reliability standards been set for the grid. And we are doing that at sort of a rapid pace, improving where we can. And then once we get that done, I think we can do a lot in building trust with all of the other partners that have to work with our infrastructure, the EV charging infrastructure, to standardize the language we use for simple things like load management and so on. Cybersecurity and data sharing requirements are another major area that historically have been lagging only because of sort of trust issues and what standards need to be set. So we're working proactively on all those fronts, and I'm happy to cover any of those topics in arbitrarily deep detail. And then we are also, many of us are engineers, and technology is what is the exciting part. It is a new fundamental transition for large parts of society, and it is awesome being part of something where we can redefine the experience for drivers. It's fun to drive an EV, and we want to keep it that way. Thank you. Next slide. All right, so next slide. Yep, there's the first sort of step of that is setting some minimum standards for what charging means from a driver's point of view. So making sure it's predictable and reliable, and then chargers are up and running when you need to charge your vehicle, and then finding a charger and not having to download an app while you're standing in front of a charger and install and putting in your credit card information. So then you don't have to worry about all of that. And building our infrastructure so we can scale up to sort of future technologies. Plug-in charge is a commonly mentioned technology that would make charging a lot easier, but building our infrastructure so it has cybersecurity built in right now, so that in the future, if you want to pay through the charger, through the charging connector, that's still secure, and some other features too that we're working on. Next slide. So, as I mentioned before, a key component of the science and reliability side of things has been to look at every interacting component in the charging infrastructure and identifying where there might be reliability issues and where there might be issues with just trust. Being able to get information from a charge point operator, for example, all the way to Bubble 6, like a demand clearinghouse that's using it as an aggregate service, and ensuring that the information exchange between these two entities is reliable as well as secure and trustworthy. I think those are the kinds of things that are currently taking up a large part of our effort on the engineering side. Go to the next slide. And in doing this, there's some highlights for what we have learned. I think looking at the charging network operators perspective, we have heard that they are under pressure to deploy chargers quickly. Many of you know that many of these companies are fairly new. They're smaller and they don't have very deep pockets, and therefore their funding and their investors expect them to deploy quickly and start building revenue. So that's a big pressure they face. They also observe that funding, federal funding and state funding tend to be seasonal. There's major grant programs that tend to have some sort of seasonality to them, which means that they have to then submit a lot of their applications for load service requests to utilities that are aligned with those funding opportunities. So there's these sort of seasonality to when there's a large number of requests. When that happens, there's these queues that develop because historically electric utilities were not used to this sort of seasonality. They were expecting a pretty uniformly distributed rate of load service requests. So they're facing some issues there. And then they notice that when they are applying for a new load service request, the queue length is uncertain. They don't know how long they'd have to wait until they put their applications in. And that is a huge factor that's affecting their ability to calculate risk and market balance, how many charges they need to plan for. And of course, as you've all seen in press fairly frequently, availability of chargers is a major customer experience aspect as well. But from the utilities perspective, there are some significant gaps there too. Utilities, would like to be engaged early in the project cycle, hopefully even before they decide on a site for the EV charging station. So before siting, most utilities cannot reserve capacity for prospective future projects. So for example, the NEVI program, we know approximately where we'd like chargers to be installed, but we can't sort of on that expectation go and reserve capacity. They're not used to the sort of interesting interaction between transportation and energy, which is that EV charging stations need to be in a place, but not exactly at that place. They can be, adjacent, 1 block away, because they're ultimately trying to provide service to people that are driving. And but usually utilities get a load service request for a particular spot, a transformer at a particular place. And they're not used to sort of then having options and being like, well, how about if you moved 100 feet down the road? It might be better for us, things like that. And then the other sort of more like esoteric issue is that we have a lot of EV adoption models. Everyone's trying to estimate what the market's going to look like and how many EVs might be in a place. But it's very difficult to use those models in your load growth estimates. So if you are planning infrastructure and upgrading feeders and things like that, incorporating the EV marketplace into that is something that is not done as far as we know, and it's something that we're trying to make possible moving forward. Next slide, please. So there's been a few things, and Sejal will be on here soon. So since she's leading a lot of these prior engagements with utilities, I will let her answer questions on these fronts. But there's a template for a utility information form that is part of that many states are including in their package. So when you start getting RFPs, when you start getting proposals back for installations, we can be clear that the contractors installing these chargers have already contacted the utility and gotten information. So that's something that we're doing to just make sure that they're proactive about these things. We've done some pre-screening for EV charging sites. I think in some states, people have spoken to the local utility and identified sites that are easy to electrify or easy to install an EV charging station at places where it's particularly hard, the lack of 3-phase, for example. And then I think on the sort of organizational level, perhaps one of the sort of positive outcomes that Sejal asked me to highlight was that state DOTs are beginning to participate in utility commission working groups, which sort of addresses that trust issues, trust not just between machines, which is what I'm comfortable with, but trust between people, which not a skill set I have. All right, next slide. All right, so let's now go to the specific work being done right now. I saw Dexter was on this call as well, and he is the absolute expert in the sort of next few slides on IQMS particularly. So in order to get an EVSE stands for Electric Vehicle Service Equipment, installed, and running, there's a whole bunch of steps that have to happen. From the utilities point of view, an engineer, has a workload. It's a whole bunch of this is just one of many other loads they're looking at. The hosting capacity, the requested site is something that they have to model, and the modeling tools to include EV charging, stochastic EV charging demands in hosting capacity are still iffy at best. So there's that. Permitting is still a delay, and then satisfying any interconnection requirements that some utilities might have for fairly large DC EVSEs. That's another thing. And of course, supply chain concerns still are abound. They're everywhere. Transformers are in short supply and chargers are in short supply. All right, so I could go to the next slide. So in terms of timelines, what we're seeing today, for level 2, that's AC charging, that about 6 months to get from an application to energization. And then for the bigger concern, I think, is the timelines for DC fast charging, which could be up to 2 years from in some cases. And then there can be longer still if there needs to be upgrades to the site, utility upgrades. So there's a significant delay at the moment, which is somewhat untenable for some of the DC fast charge operators. So next slide, please. So there's a larger DOE effort, multiple offices, and I won't talk about this too much because there's the people that came up with this and run this program are on this call. But they're across the board. DOE is working on improving distributed generator interconnection with the grid. It involves addressing this issue at multiple levels, and reliability and resiliency being one aspect, but also sort of building the community stakeholders, analyzing data we're getting. This is just generators at large, distributed generation and interconnection with the grid. But a subsection of that, if you go to the next slide, is IQMS, the program that I referred to earlier. It is a program that has $11.2 million, and it is primarily focused on providing funding to distribution utilities to try innovative things to speed up their interconnection queues. So it's both process improvements, like better modeling tools and better internal workflows, that's totally within scope, but also technology solutions that would help. It has two tracks, this program. So there's distributed generators as well as electric vehicle charging. And distribution utilities can, if they're using the same queue for both of these types of load service requests, they're welcome to combine these things and propose something together or individually. So this is the sort of IQMS program. It's a whole bunch of partner offices and labs that are working on the sort of data analytics side and project management side, and of course on the funding side. Next slide, please. So this is the link to the DOE site that gives you more information about IQMS, and your applications are due on October 16th, so not too much time left. So if you know some utilities that have ideas that they would like to try out, please go to them and encourage them to apply. Next slide, please. As I mentioned before, IQMS has two tracks. The first is pretty traditional DG speed up. So it's interconnection queues. If you have PV up to about 3 megawatts, something like that you're considering, and if people are asking for that to be installed and you want to speed up your internal processes to approve it, then there's funding to help you try out solutions. There's two phases for everything. There's a sort of preparation phase and a demonstration phase, and I won't talk to a slide, so you can read this later. Next slide, please. And then just identical in sort of program structure is the electric vehicle supply equipment load service request track, which is also 8 months of preparation and 2 months of demonstration. The idea is that we'll fund up to 10 utilities to try this. And when we say utilities, we mean that utilities are the sort of the prime, that's our focus, but in many cases, some sort of consulting firm perhaps is operating as a prime. That's allowed. Next slide, please. There's, as I mentioned before, you could try implementing energy management, load control technology, improving your AMI infrastructure to give you real-time feedback, so it might help you build trust. So grid edge measurements, but also doing studies. So for example, like coming up with some template language for EV charging load service requests for a certain region where you know what the feeder constraints are, and then very clearly identifying grid codes and things like that might help them propose a more complete load service request to you. And then any advanced hosting capacity services and tools are also welcome as proposals. Next slide. There's a timeline. Next slide, please. And that's the end of this presentation. And that's a QR code if you want to take a picture, but you can just search for IQMS as part of I2X. Thank you very much.
Thanks, DJ. Really appreciate the presentation. If you could stick around, we're going to do our next two presentations, and then we'll bring you back on for Q&A. If anyone has questions that you'd like to ask DJ, feel free to put them in the chat now if you don't want to forget them, and ask them live at the end of the next two presentations, whichever method you would like to use, either chat or ask them live in a few minutes. But next we get to hear from Britta Gross, who is the Director of Transportation at EPRI. You have probably heard her talk about the E roadmap at some point in the past, because it's a really fantastic tool that Britta and her team have been putting together and incredibly useful. But maybe you haven't heard about the GridFast initiative that she's working on too. So I'm really excited for this presentation. And for those of you who don't know Britta, she leads the Electric Power Research Institute, or EPRI's transportation program, as well as the EVs to Scale 2030 initiative, and is responsible for defining the market strategies needed to accelerate the electrification of the transportation system, with an urgent focus on identifying the critical gaps that need to be addressed to achieve 2030 climate-aligned goals. So with that, I'm going to turn it over to you, Britta, for your presentation. Thanks for coming.
Thank you, Commissioner. Let's go ahead and go to the next slide. Thank you all. I wanted to just frame up GridFast so that you have a chance to understand, again, what's the context of EVs to Scale? What are we doing here at EPRI? And then what's the, how does GridFast fit in? So let me just show you one slide about what EVs to Scale 2030 is. A couple of years ago, we stepped back and said, what are the things that will prevent us all from getting to scale by 2030? And the things that EPRI could affect, right? It's mostly utility related things, the grid. It is a relationship with automakers and truck makers and fleet operators too. But what can we affect and what has to be solved, or we will not get to scale? And so we created sort of this three-column, this three-pillar approach. First column is we're going to need better data. We're going to need data that drives confidence into the marketplace. This is what's happening. Don't worry about reading the headlines. Those always change. They are cyclical. What's the data say? Where are trucks today? How are they transitioning to electric? Where do they dwell? Same thing with cars. What is residential? What is workplace? What is long highway type of corridors for light duty vehicle traffic? What's the data? What are those folks that are accountable for making trucks and cars and buses and the fleet operators that are purchasing these vehicles? What are they actually doing? So that's column one, really. Getting the information that drives confidence for all of us to make really responsible decisions about, can we proactively ready the grid? Second column, the processes have to evolve. The utility industry, for example, has for 100 years developed processes that have really worked to support building electrification. A building can take 6 months, or it can take 2 years, or it can take 20 years if you're a housing development. That's not how the transportation industry works. Cars and trucks today, electric trucks can be ordered from Daimler or Volvo Truck or Navistar or PACCAR, and you can have a dozen electric heavy-duty Class 8 trucks in your depot in about 4 to 6 months. That's different than the timelines for utilities that might take 6 months, a year and a half, even 3 or 4 or 5 or 7 years if we're talking about a substation that needs upgrading. So, and I know a lot of you folks know that already. But we have to look at this mismatch in timing because it's already creating bottlenecks and issues, and we've got to address this or we will not get to scale. So these are the processes that don't work. We've got to streamline them. Third column, what are the tools we need to actually change and inform behaviors? Can we create some tools like eRoadmap and GridFast to come that actually inform with data, making it very public, making it very available so that folks know what they're looking at and the confidence that it drives? We might do pilots, but that is not the focus. We've done a lot of pilots in the last 15 years. They might be targeted and surgical, for example, on load management, et cetera. But for right now, we're focused on the tool part. There's a lot of interplay between these three columns: data and stakeholders, streamlining processes, and the tools that need to actually get out there and maybe change the way we interface between industries. And I'll tell you a little bit more about that in a second. Underlying everything is taking all those learnings and knowledge, turning it into action through regulatory and policy, education, also equity and workforce. There are some considerations there that need to be taken into account, or we will also not get to scale, and we won't do it the right way. If we go to the next slide, just want to quickly show you that Commissioner Paratek is actually on the board of this initiative too. We were very careful a couple of years ago, a year and a half ago, about making sure that every primary critical voice is looking at this initiative, participating in its shaping, and that we're not missing a beat. We're getting this done right. So we've got Patty Poppe, the CEO of PG&E, actually chairs it this year. It was being led by the CEO of, or the key executive at Xcel Energy. Now it's Patty Poppe leading this effort. You can see a number of utilities in here representing IOUs, munis, and rural co-ops. You see the three leading utility trade associations and LPPC on the first column there next to Rachel Wong's name with SMUD. But the three leading trade associations for utilities, APPA, Public Power, EEI, IOUs, and NRECA, the rural co-ops. You see Commissioner Peritic here representing NARUC and the EV Working Group. Phil Jones at ATE. John Bozella is the CEO of the Auto Alliance, basically all of the light-duty vehicle manufacturers in the U.S. We've got a representative of leading truck fleet operators. That's Amazon. We've got Caterpillar, another stakeholder in the enterprise of getting electric vehicles on the road. Daimler Truck, the voice of truck manufacturers, also with Diego Quevedo. And then the Joint Office has a board seat also. That's Rachel Nealer here. So just again, think big. Let's get this right. Let's not make a misstep here. On the next slide, let me now just show you and remind you all, if you haven't seen this yet, what is eRoadmap? The first tool, it's a public communications tool. It was about getting the data right and doing something that had never been done before, and that is, how many data sources are there out there? Could we assemble as many as possible and the ones that matter most in making decisions about grid readiness? And so we've got a bunch of analytics organizations that we work with, including RMI, Department of Energy, and NREL in particular. But below that line is the data. This is really what we work on almost every day here as we try to bulk up and beef up. What do we know about who's acting? What are their plans? What's happening this year, the next year, the year after? What happens between now and 2030 to prepare the grid for large scale electrification. So on the right-hand side of below the line, you see 4 purchase data sets. This is what most organizations know they have available to them, but we've got all 4 of them: Experian, Geotab, INRIX, and Replica. I won't go into detail here today what these all are, but we beef this up with our knowledge and data, telemetry data for the most part, from organizations like Daimler Truck, Volvo Truck, Navistar, PACCAR, the 4 leading heavy-duty truck manufacturers, because the truckloads matter. The light-duty vehicle load across the United States is a bigger, much bigger load, but it is quite evenly spread, almost peanut butter spread across the United States. So they don't jump off the map as far as grid readiness goes. There are spots, of course, that we have to pay attention to, but it's the truckloads that almost always jump off the map. Where trucks congregate and dwell, that's where we're finding some real pain points. You can see Amazon's provided all of their electrification plans, Pitt, Ohio, Manhattan Beer, etc. This is what we work on every day. Those are really known plans that they've agreed to share with us, and we have them anonymized and aggregated inside eRoadmap. Let me just show you on the next slide what eRoadmap looks like. In case you haven't seen it yet, please play around with this tool. Go in there. We've done it for you. It's there for decision makers and other stakeholders to know what is available, what's at your fingertips, and so that you can make better decisions and be informed about the loads that are coming this year, next year, the year after, at a granular feeder level across the United States. It's at eroadmap.epri.com. You can see the United States at a glance, but you can also zoom into any feeder in the United States and have a look at what the loads are projected to be at those locations, either light duty or heavy duty and medium duty. We sort of separate those numbers for you. So that's what it looks like. There's a timeline associated with it, depending on when Amazon and Manhattan Beer and others are, when they're electrifying, and when we see the targets and the mandates taking effect in different states like California, New York, etc. I think enough said on this one. Let me try to get to a couple more examples. So if we zoom into, for example, Lansing, Michigan, and we now look at the timeline right in that Lansing, Michigan area, just an example of what you can do yourself. We see these sort of colors pop off the map. Colors mean, darker colors mean there's more load in those areas than in others. So I glance at this 2027 map over here on the left-hand side. Yes, we have Hawaii and Alaska on the map too. Thanks for the question. Let's go look at that very leftmost dot. I'm only going to do this once. Look at that leftmost dot on the map at 2027. What is that dot in the Lansing area on the west side of Lansing? If we go to the next slide, let's see what it tells us, what the information is in eRoadmap. All right, here's a load that shows up in 2027. I actually know I think it's the same number in 2026. Oh, there it is, 2026. And you see a load that looks like about 13 megawatt hours if my eyes are good enough. And it's all coming from medium and heavy duty trucks. There's almost no load in that hexagon, 0.28 square miles, that is light duty vehicle related. It's all medium and heavy duty. So if we now look at the satellite view, who operates in that hexagon? Well, Amazon's got a warehouse there. Myers has some distribution centers in there. Bridgewater Company Interiors, I don't know who they are. Android Industries and Ryder. You might recognize the name Ryder. Well, you know, and I know that Amazon's data is 100% accurate. It's their plan in this thing, anonymized and aggregated. I can't tell you if that's exactly what's driving 13 megawatt hours. That's our agreement. We won't expose anyone, but they want you to know, Amazon, that they want to send demand signals that are certain so that the grid is ready when they plan to come to whatever feeder in the United States. So this is how you use this. It's how utilities can look at this and say, 13 megawatt hours, I'm not worried, or maybe I am worried. Let me see who operates there. Oh, I don't know what Myers is doing. Maybe I ought to make a phone call to Meyer. I know who they are in my area. So that's how you use the tool. It informs you about load forecasting. If we look at the next slide, let me just talk for a moment about hosting capacity. What we've also begun adding to this map now are the hosting capacity maps where they are being made available by utilities. This is a newer kind of methodology and availability of data. So this is going to take us a little bit of time unless we really push for this. But what we see is in eRoadmap now, we have now for the first time that I'm aware of integrated the first 14 available hosting capacity maps. How much capacity for load is available in different areas of the country. You can see California's got a green area over there. You can see sort of the Northeast, some utilities in New York, maybe I think Pennsylvania might be included there. You see Maine also is now, we've got some data from Central Maine Power and also down in Delaware and I think some New Jersey utilities. What does that mean if we zoom into one of these areas where hosting capacity has been provided? Well, I'm going to go glance at 2028, that little snapshot there in the middle, and I'm going to look at a blue dot. Look at that blue hexagon right there. What does that tell me if I zoom into that one? It tells me that there's a forecasted load in 2028 of 14 megawatt hours, almost all coming from medium duty trucks again. And if I look down at the bottom at the line capacity, the feeder capacity at the feeder that serves that blue hexagon right there, it shows that in 2028, Eversource is now showing a 0.4 megawatt, that's in power now, megawatts available on that feeder line. The question is now, is that sufficient to serve 13 megawatt hours? That depends on the load shape, and load shapes are coming very soon to eRoadmap. Very soon, next couple of weeks, we'll have some power numbers also available, so you can really connect apples and apples here. But that's how you use it, and that's why we'd like this capability to grow, because fleet operators across the country tell us this would help them immensely to know where is capacity available today to make their jobs easier, and know that they can probably, they'll have to discuss this with utilities, of course, but sort of at a first glance, it looks like there is capacity or there's not, and they could prioritize other sites that they operate. All right, next slide. Here's the status of which utilities are in the map right now. You can just cast your eye down this list. We've got another 1-2 dozen utilities that we're working with now that are beginning to procure these maps for us as well, and we'll continue to integrate them as soon as we have the data from these folks. So just so you know. Let me now just go over to Grid Fast and finish this up for my presentation here today. The whole key here was to fix that timing mismatch problem. The whole goal of this EVs to Scale large program that we've embarked on. It's to take what used to start only with a service request, a fully filled out application for service and one fleet operator or charging provider talking to a utility. And the problem is if we wait for a service request, we are so far down the road where the fleet operator probably knows that trucks are coming, and you have 4 to 6 months to ready the grid, and that's not enough time. We have got to push awareness of where and when the loads are coming far to the left in here, when it's just a vision of a fleet operator, when Amazon knows their plans for the next 8 years, or a FedEx or a DHL. We must begin to share that information in anonymous, aggregated, anonymized ways to not hurt anyone's competitive interest. That, of course, we do not want to do. So how do you move the timelines to the left? Well, eRoadmap is one way. Put the data in there, make it visible, and safe for everyone to share. Let's go look at the next slide here. We interviewed a lot of organizations, fleet operators, charging providers, utilities, and others. What are your pain points in this interconnection process? And I'll just sort of make this short by saying these are all important things. In yellow, I've highlighted the things that jump out at me the most commonly complained about either by a fleet operator or by a utility, the difficulty in working with transportation operators that want to put charging in the ground. Over there to the right, that rightmost yellow area under design and engineering was a request, please, could we try to standardize the service request forms across 3,200 utilities, because it is a pain point for an Amazon or a FedEx who has to deal with one form that looks nothing like the form for another utility. They're asking different questions. They're using different vocabulary. So I wanted to just sort of introduce this 15 pain points, which is the goal of GridFast, by just zooming in on the one thing that's the standardized service application form. So let's go on to the next slide. So imagine an online portal up in the cloud that takes information from anyone who's got a transportation related project for charging, et cetera, like level 2, heavy DC fast charging, whatever it is. And that information goes as soon as it's knowledge to one of the organization. Hey, in 3 years, I'm going to be needing some charging at that site. I think it's 1 megawatt or 1.5 megawatt, or it's 400 kW, whatever it is. It goes in a very confidential way up into the cloud, and that cloud right there addresses those 15 pain points on the previous slide. Can you match me to the right utility so I don't have to figure out who's on the west side of Kansas City or who's up there on the south side of Detroit? Match me to a utility. Who do I contact there? And can you show me the common service application form that sort of has most of the information every utility is going to want to know? And then that goes to the correct utility in the country. And the utility can also begin communicating with that operator. Here's the capacity on that line. It's going to be an easy project or a hard project. There's a lot we have to learn still about this process. But if you're familiar with the College Common App process, where universities got together, created a portal for every college applicant to not have to just find the university's website, upload a resume, upload their test scores over and over again. Now it goes to a common college application portal. That's what this is. Imagine this now for service requests years in advance for charging projects. And if I just go to the next slide, I'm almost done. It has project input you give as if you're managing and planning a project, a charging project in the future. You match to the right utility in this tool. You share capacity information as part of the sort of the first communication between utility and customer looking for some load. And then at the end of the road, there is a pre-service application form that begins to collect all that information that the utility is going to need to have. And then finally, on the next slide, here's what it looks like. Imagine that we're not going to try to get 100% service application standardized. That's never going to happen. We knew it was beyond possible. So we are commonizing sort of the, say, 70 or 80% of the questions that everyone must ask. So what are the top 70 to 80% of the questions that can be commonized, that where PG&E agrees with DTE, agrees with Eversource and Con Ed? Can we agree this is the way we collect the data, the first information, and this is the common vocabulary? And then every utility can ask whatever other customized questions they want to ask that's in their service request form. But we don't want to try to overbuild and overdesign this when we could never get agreement on the other stuff, because some of that's just local in nature. So imagine common questions and then customized questions for the utilities. So, and then finally, the rollout plan will roll out first to the funders of this program, the members of the EVs to Scale project. You can see on the next map. Here are the participants in this program that are helping shape all this interesting stuff. These utilities on the next slide, they want to see this happen. They have bought into this idea that we're never going to get to scale if we can't address some of these issues. And I'm not seeing the next map, but maybe you guys can see it. And there you go. There are the funders. It looks like there's a lot of geography missing, but these are very large utilities for the most part. A lot of that land in the middle is sometimes also very low population land. But still, we're working on gaining more members and participation in these tools. We'll see what we can do to get this usable by 3,200 utilities, for example. And then finally, everything's wrapped into this regulatory policy outreach. We can't lobby at EPRI, but we can educate. And so we are taking the learnings from eRoadmap that I showed you before, the load forecasting and hosting capacity maps, taking out what can we extract for each state, what you should be noticing if you were using eRoadmap. Take a look at what happens in 2027 or 2028 in your state. Here's where you may be wanting to look. Here are the hot spots you may want to start addressing now, because we're running out of time and you've got very little time to address these loads if you want to do it in advance of when the loads are actually going to happen. And so on the next slide, you see the 50 state decks that we're beginning to put together very shortly. We'll begin to make these available to the different states. Again, trying to make more personal for each state. In the big scheme of everything being, there's a lot out there, there's a lot going on. Can we help you focus on what you need to know? And that's it. That's the outreach for the regulatory policy work. We'll work with a lot of NGOs on this. We'll work with other organizations. And that's it. That's all I have for today. Looking forward to questions. And I'm always here if you have questions afterwards as well.
Thanks, Britta. I think you're going to get a lot of questions from that. That was a ton of information, and really appreciate you trying to fit all of that into the 15 minutes that we gave you. So it was very comprehensive. Everyone will be able to see these slides afterwards and be able to go through it a little bit more slowly on their own as well. I just wanted to note for the EV State Working Group members who are on the call, I am on the board of the EVs to Scale 2030, but I'm representing the state utility commissioners. So I take a lot of what I get out of these meetings with you all, and then bring that knowledge and to that board for EVs to Scale 2030. So I'm not representing Michigan. I'm representing all of the utility commissions, and I really appreciate all of the knowledge that I get from all of you on these calls. Okay, next speaker, we've got one more presentation, and this one is from Paul D. Martini, excuse me, who is a managing partner at Newport Consulting and is a leading expert on the business, policy, and technology dimensions of a more distributed and resilient power system. Over the past decade, he's supported distribution grid transformation efforts with over 20 utilities and the U.S. Department of Energy, and provided technical assistance to over 25 regulatory commissions, and has also supported efforts in both Australia and Canada. So with that, I'll turn it over to you, Paul, for our final 15-minute presentation. And then after that, we will open up to questions for all three of the presenters. All right, Paul.
Thank you, Commissioner. And I apologize, I have a cold, and so my voice isn't quite as clear. What I'm going to share with you today is some findings from a recent paper that we've published as part of the Office of Electricity's efforts on distributed grid transformation. The paper Flexible DER and EV Connections is available on the DOE website. And what we focused on in this paper is how are we evolving beyond where, what the two prior presenters are describing, which is an excellent first steps towards advancing greater integration of EV charging. And what this paper is focused on is how do we start to think differently about how we do hosting capacity analysis, not unlike DJ touched on very briefly, but how do we move to a more dynamic analysis of hosting capacity capability on an hourly basis across a year, so that we can then better understand how we might be able to work with fleet operators and large public charging installations to be able to align their demand to fit within that hosting capacity. As some of you are aware, hosting capacity analysis tends to be fairly simple today in terms of identifying a peak. And here's a couple of efforts going on in the US and also being pursued in Australia, largely around PV charging, PV exports, and looking at flexible connections for PV. But the same technique is being applied to EV charging, which is what we'll talk about. Next slide. So as you're aware, how we think about conventional interconnection and thinking about hosting capacity limit, it tends to be, as I mentioned, fairly constrained to kind of certain periods of the time and kind of simplistic, relatively speaking, in terms of setting the limits. What we're talking about here is something much more dynamic, and in particular, more on an hourly basis across a year, so that there's a more, more flexibility in thinking about how much in this case, an EV charger might be able to charge the demand on the system at any given time. Next slide, please. So as I mentioned, hosted capacity, we've talked about thermal capacity limits. Obviously, there's voltage limits and there's protection coordination are important elements. And it has been increasingly gotten more sophisticated in a number of states in terms of how the analysis is done. Certainly, California is doing some advanced hosting capacity analysis, but there's still more that can be done. And as we think about moving away from a static assessment into something that's more, dealing with the random variability of how charging might play out, that sort of analysis to be able to do something more specific on more granular time intervals is where we're moving to. And that's a term that's really originated in Australia called dynamic operating envelope. So the idea being the operating envelope is essentially the hosting capacity. So what are those parameters under which at any given moment the grid might have a certain amount of headroom that it could accommodate incremental PV or in this case EV charging loads. Next slide, please. So in terms of dynamic operating envelope, excuse me. So similar to what was just described by Britta, identifying the specific locations, and this could be done through prospective analysis as was being discussed by both DJ and Britta, looking at where those locations are and being able to understand specifically the real and reactive power exports and imports that might be at those points. And then, within the constraints, those time intervals, and as I said, they're typically hourly now. So, here's where AMI data can be very useful in terms of doing this analysis. So the result is very time-specific operating limits around those dimensions: voltage, thermal, and protection for EV charging based on the capacity in each of those time intervals. And then the approaches that are being looked at it's essentially a curtailment type approach, but there's two ways that this is being pursued. One is to have customer controlled limits in terms of the customer basically manages their demand within those limits that are relatively dynamic, or it could be through a utility direct control curtailment or derate of those imports or exports. Next slide, please. So in terms of the customer controlled solutions, the approach here is to really provide the information to the customer. And this can be done on a prospective basis on a preset schedule based on the analysis that was done, based on forecasts, or it could be done on a day ahead basis in terms of providing the information on the limits, specific limits that they could pull from the system in terms of their demand. And then the customer themselves controls their charging to stay within those limits. There are technologies available so that can be done automatically. So it's not doesn't necessarily need to be a human intervention kind of a system. And this can also, what the intent is to allow, faster and lower cost service connections as a result. Obviously, you can free up a little bit otherwise perceived headroom in the hosting capacity that can allow more interconnections of resources. And the direct control solutions here, the utility would curtail the DER or the EV charging in this case based on the capacity available. And it would use their control systems to do that and interface with the customer's equipment to make that curtailment. In this case, when a utility is doing the direct control, you need to have a method to basically determine who gets an allocation of a curtailment. And that creates some additional challenges to think through how to do that curtailment, that determine how much reduction each would need to have. And I'll touch on that briefly in a second. Next slide, please. So I'm going to share with you a couple of examples of how this is being done. In terms of customer controlled, Southern California Edison has a pilot underway called the Load Control Management System. And this is designed to focus on fleet operators and large public charging facilities with an intent to help increase the hosted capacity, if you will, or allow more EV charging, large EV charging loads to be integrated in the system that might otherwise not have been available or possible under the prior sort of hosting capacity method. So this program just got approved a year ago, isn't underway. I think on the next slide, excuse me, it shows a little bit more of the details where there's really two options for this. So again, in this case, Southern California and Edison provides the engineering analysis around the operating parameters, that is the limits that the demand can be had by the EV charging. And there's basically two options. One is the customer system can operate independently without real-time external communication. And that could be the information provided on a pre-programmed limits that are provided, by SoCalEd to the operator, and then the operator itself can program their equipment locally to stay within the limits, or it can be programmed remotely via communications by SoCalEd through with the customer. The other is that you can have utility-based communications in real time or day ahead from SCE to the customer's controller, and then it goes through a standard set of protocols. In both cases, the customer ultimately is responsible for managing this and the demand within the limit. So the utility doesn't have direct control over the charging, but rather provides the engineering parameters under which the customer's facility needs to stay within. Next slide, please. There's another approach, which is a pilot that National Grid's been doing, and this is more for light duty vehicle focus. And here, although as Britta mentioned, this has been less of an issue, although people realize that this is a coming issue. The fleet and large public charging is really the kind of more urgent issue, which is what SoCalEd's focused on. The other approach is to look at how to manage charging, from a utility control and curtailment type program. And here, National Grid has got a pilot program, EV Charge Smart Plan, where they've been looking to work through light duty vehicles, telemetrics, and for charging in the vehicle, as well as residential EVSE charging, smart chargers. Next slide, please. We'll show a little bit more detail. So in this case, one of the challenges that they've had is that in terms of being able to work through the telematics systems, they found that only BMW and Tesla were able to integrate with the system that they were planning to use in terms of the standardization, and so they did incorporate those two manufacturers' vehicles in the program. They also, as part of their communications, interface directly with the EVSEs connected through the home Wi-Fi network. And their backend system basically manages this in terms of what the charging is, how does this fit within the capacity limits of the system, and then makes the adjustments in terms of curtailment. So this is like a managed charging program. It is a managed charging program, but not for the purpose of doing demand management, but rather looking to integrate this into being able to address hosted capacity limits on the distribution. So it's a variation on what you may be familiar with in terms of managed charging systems, but here not so much for demand management on the bulk power system, but rather managing at the distribution system. There are challenges as we start to look further into these utility control-based systems, if they're going to be used, particularly in the light and light duty and vehicle category, and particularly for residential type customers. The communication links are not very reliable. Obviously, Wi-Fi at the home is not the most reliable network communication to depend on. And the vehicle telematics have been a challenge to interface with because as software updates happen at the vehicle or at the EVSE. They've had software changes. The interfaces have changed, or protocols changed, and so then they've had to reconfigure those. So this has created some challenges. So something to think about going forward as we look at this. They're going to continue to pursue this program and look to try and work out some of those issues. But it does look like some of the autonomous or customer-oriented systems can be pretty reliable and fairly straightforward to implement through the utility providing more dynamic information in terms of capacity limits that are more granular in terms of, say, the hourly approach that SoCal Edison's using. By the way, the SoCal Edison EV program is very similar in effect to what the California Public Utility Commission ordered earlier this year for PV integration, distributed PV, which is called limited generation profiles, which is essentially a dynamic operating envelope approach to PV integration as well, using sort of hourly type information and allowing the customer to manage that curtailment or D-rate based on the information provided by the utility. Next slide, please. In terms of if a utility is doing curtailment, there are really two determination methods. Neither one is very mature in terms of how this is being used. And this is the case in Australia, where this is really kind of started in earnest. There's really this last in, first out approach and a pro rata approach. Both of them on their face sound, like they could, work out, but the reality is this becomes quite complicated, which one to choose. And the bottom line with respect to EV charging in particular is that curtailment programs only are good for a little while, because ultimately, as more loads come into a particular area, you're going to run out of capacity, even with the curtailment management. So, the way that we are thinking about this is really, this is an intermediate step that can help advance beyond the initial steps that Britta and DJ talked about. But we clearly need to think about how we're going to be orchestrating more broadly distributed resources more holistically to be able to manage the constraints on the distribution system to address affordability. Next slide, please. And I'll stop there. Rosalie Yu at ICF is a co-author of the paper, and Joe Palladino at the Office of Electricity is our sponsor. If you have any additional questions, and there's additional papers on how we think about are thinking about distributed resource integration and utilization on the DOE website there on the URL listed at the bottom of the page. Thank you.
That's perfect. Thank you so much, Paul. Appreciate the presentation, especially while you're in the middle of a cold. Really seems like there's a lot going around right now. So thank you for taking the time to do this, even in that state. We've got quite a few questions in the chat. I'd like to start with two of the questions that are in the chat. So if we could bring all three of our presenters back on camera and take the presentation down, we can go to our Q&A session. I do want to allow as much time as we need for the Q&A for our expert presenters. So we can cut into our peer sharing discussion just a little bit here. I know 15 minutes is not long enough for most of the information that we asked you all to present today. Britta, I actually just wanted to start. Eric from Ohio noted that the e-roadmap is mostly populated by telemetry from ICE trucks to see where they go and where they sit. And I just wanted to I think maybe start by clarifying that it's the e-roadmap is actually populated by by company plans to build the chargers, not by existing ICE truck distribution. Do you want to elaborate on that a little bit?
Yeah, I was trying to hammer out, Eric, another answer to you, but it was taking me too long. It's very complicated, to be honest. There's so much data in eRoadmap because we want to fill in all the gaps and be as, provide as much insight and confidence as we can. So the foundationally, it's all the mandates and regulations. If you're a state that has to meet ACT and ACF, it's what shows what's going to happen in 2027, 28, 29. Those have to be met. Those are laws. Greenhouse gas 3 is now the law of the land. That has also an impact. We had to interpolate and figure out what does that mean to all the different states. There's also a lot of registration data. Where is every car, bus, and truck located today in the United States? But really importantly, and then there's the telemetry data from the heavy duty trucks, because that in particular is a heavy load that just has to be understood. Where do the trucks travel and dwell? Because registration data for trucks is not always very good. A lot of trucks are registered in Maine and Indiana, and they're not all living and operating there. So we had to be much deeper than that. So we have that diesel data telemetry since 2015, every one of those manufacturers to tell us if that turns into electric, and we know the mileage of them. We're about to put a button on eRoadmap 2 that says, if you don't believe this is 500-mile and more trucks are going to a day, trucks are going to be battery driven, they're going to be something else, fine, push the button and say, just take off the 500+ mile a day trucks. And the map will now show those gone. So these are important features we're bringing to play here. But most importantly is what Commissioner said. And that is Amazon, FedEx, all those companies that I'm still working on, when they share their actual 3, 5, 8, 10-year plans with us, those are in this, they're buried in the data, and those you can count on, which is why when I show examples of maps, I try to look for something that's got an Amazon or a FedEx or a company where I know that that's real data, because that you can almost 100% count on. That's their plan for which depot in the United States is now in what year is going to be electrified. So it's a combination. One day, I'd like all the fleet plans, all the charging provider, all the building developers like Prologis, I'd like all of their plans known in advance of when it's going to happen, as many years as possible, and crowd out the stuff that's just a forecast, what the regulation says you have to do. I'd love to crowd it out, but that's the complexity. Everything is documented very transparently on the eRoadmap website. Look for like documentation links on the left-hand side. We've documented everything, so we're transparent with you all.
Thanks, Britta. Yeah, that was a great explanation. The other question that I wanted to start with is for DJ, and it also was from Eric in the chat. I had a similar question about the average application times that you showed, DJ. You showed 6 months as an average application timeline for a level 2 charger, and then 2 years for the fast chargers. I guess my first question is, what are the primary drivers for those long energization timelines? Because 6 months for a level 2, that's kind of concerning. I doubt that's coming from the utility, that connecting a level 2 charger is really not that much additional capacity or load that goes onto a utility's system. But if it is, I would love to know that. And then the rest of Eric's question too is describing the sample size of the research that came up with that data. And then can you share the bottom quartile in time, and can you share the observations from Oregon?
Yeah, I think for the 2 years that was up to 2 years. So it's not the average. And in terms of statistics, I think Sagel's on, so thankfully I can call a lifeline here, because she's the person that interfaces with utilities. So I think it is utility information though. So I'll let Sagel answer specifics on where that data is coming from.
Thanks, DJ, and thank you for hi all. Sorry I joined late. So on the level 2 side, that information came from an IREC report. I think that's at least referenced in the slide. That is from the IREC report that was done back in 2022, I believe, late 2022. And then we, on the joint office side, had done our own informal survey of EVSPs of the manufacturers and vendors for sites, and especially on the DCFC side. So we do not confirm the level 2. The DCFC timeline of up to 2 years was still the same in December, January of 2023, 2024. That timeline still stood. And that's without the need for utility side upgrades. That is just that load service request that they're asking for. that was taking them up to 2 years, depending on, where they were. And I didn't catch the second part of your question, Commissioner Paratek, but I hope I answered the first part.
I guess, is that true for so that's helpful and concerning, but is that also true for the level 2 charging, that that it's taking the utilities 6 months to connect something at 480 volts? That's
what the IREC survey showed, but we did not reconfirm that with the VSPs in 23-24.
Okay. Interesting. Okay. Well, thank you. I have one more question for DJ and Sejal, and then if anyone else wants to jump in, please do, either in the chat or just turn your camera on or raise your hand or just start talking over me. That's fine too. But my one more question for the two of you is, what has been the utility response to your IQMS project? Do utilities seem interested in participating in this?
I mean, it's difficult to say. Applications are due October 16th. But our portal, we can tell if applications have been started. We don't know, we don't have access to the portal yet, so we don't know who started them or how utilities are connected to the project. So it's very difficult for us to say, how well, give you like a data source. Generally speaking, anecdotally, I think I've gotten positive feedback from folks that work with utilities or directly from utilities, that it's a good effort and needed effort.
Okay, that's encouraging. Thank you. Ryan.
Yeah, thanks, Commissioner. Thanks you all for these presentations. They're great, really awesome information. My name is Ryan Cheney. I work on electric transportation for the North Carolina Utilities Commission. And we are increasingly, focusing on this grid planning aspect, kind of moving away from the, making sure there is enough chargers out there, which is really key, and the utilities' role in that, but more into this grid planning space. And I'm pretty sure, as I recall, that Duke Energy is the primary utility regulated in North Carolina. They have been using a tool from Guidehouse to do a lot of this modeling. And I need to dig deeper, Britta, into the EVs to scale work. It looks awesome. And my question is, if you have any thoughts on kind of the different, opportunities that utilities have, different models they have. I think RMI has a tool. How much you're able to kind of wrap your hands around kind of the different ways that utilities that we all are working with may be using different tools, and sort of how to know the differences between them, or where there's best practices that we should be thinking about in evaluating sort of the effectiveness of those forecasts that may be coming from tools other than EVs to scale.
Yeah, I mean, so we work with RMI. So RMI's tool is really LD, light duty vehicle centric. That's where they put the effort. We were waiting for them to do it. We've been working with them for the last year and a half. And we now have their data. I don't know if it's in the public version yet, but it's like we have the data, we just have to put it in. So they will be responsible for light duty vehicle, because we think that they've taken it a notch further, and we have our hands full with trucking. Trucking is really complicated. We think we have the most sophisticated trucking stuff because there's so much data coming together, and everyone's been able to share data with us. So I would just say that we also integrate everything into one place. So this is a great place to pull together the light duty and the heavy duty stuff where it's meaningful as we can get it. We've documented everything. We're getting the fleet data as fast as I can. You can always push people to us, please. It's really hard to get this data. Everyone starts off really nervous. I got to talk to lawyers. It's like, come on, like this, we've made this easy for you all. Help us get this done, because it's the only way to drive confidence and inform folks so that regulators, executives at utilities feel more comfortable that the load is going to come when the grid is prepared. So, that's been the premise here. So I can't speak to any other tools. I don't know that anyone's ever tried to do so much just to get data out there and make it really known how we're doing this and document it completely. So I would just say that's what we're doing.
Yeah, makes sense. Thanks.
Yeah.
Anyone else want to get a question in before we go to the closed session? Okay, well, I guess not. So thank you so much, Britta, DJ, Paul, for your presentations today, and Sejal for the Q&A. Really appreciate this. These were a lot of information in these presentations, and I found it really valuable, and I think all of our members did too. So thank you so much, and we'll now switch to our closed discussion. Thanks.
Bye, guys.